These shapes might look complex, but they are easy to code. All it is to it is just a regular polygon outline and maybe another regular polygon in the middle, and join up the corners, fill them in with color, and then we're done. Easy, right? Let's get into it. Now, we're going to have five regular polyhedrons drawn, as there's only five such regular polyhedrons: the tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. This is also known as a cube, and the hexahedron is also known as a cube, as I was saying. And we're going to have import actually from turtle import all, just to make the code much simpler and use less characters from import all, and then speed 0 car so that it doesn't take forever to draw. High turtle so that the turtle doesn't ruin the views. Color mode 255 because I prefer 200. And so we're now at the point where we are going to define how to draw these polyhedrons. So we're going to start with the tetrahedron. So define tetrahedron, and then we're going to have size, color, heading as parameters. And for the tetrahedron, simply draw three isosceles triangles, fill them in different shades to, to create the illusion of depth, and that's it. That's how we're going to draw the tetrahedron. So set heading minus heading. And then for I in range 3, so that we could draw three triangles, fill, color, uh, in color 0, divide by I plus 1, and then the reason why I use int is because because this color mode only takes integer values, so we have to convert them into integer. And no, we're not going to do that because that's just going to be a list index out of range error. And then we need a comma here as well, and also begin fill so that when we actually draw the isosceles triangles, uh, where we'll so that when we actually draw the isosceles triangle, then we will then it will also be filled in. So that's called size. What is it? Next task again. Left. No, left. Turn left by 150. Turn left by 60 degrees, and then we'll just go to. I could just do it in a loop, but that's just more context. The forward size times root 3. Nope. Left 150. So that's a full triangle, full isosceles triangle done. And we're also going to configure the triangles in position so that it actually looks like a tetrahedron, not some other shape like an octahedron. Left 150. Nope, not 150. 30. Forward size times square root of 3, and then left 210. And so I will explain what I mean by square roots of 3 in a moment. 255 0, then 330. So when I'm talking about yes, there's an error. Yes, I put a typo, and then it just slashed off. So as I was saying, what I mean by the square root of 3 is that this side length is 200 pixels, this side length is 200 pixels, and this side length is 200 times square root of 3 pixels. Because this angle is 30 degrees, this angle is 30 degrees, and this angle is 150. 120 degrees, and if we cut that up, we have a 30, 60, 90 triangle, and this side length is 200, this side length is 100, and this side length is 100 times square root of 3. This is all basic trigonometry, and I won't explain further. So that's a trigonometric math part done. and now back to where we were. We go to up, go to minus 957, minus 100, and then down, and then we're all set in position, and then now we're going to now we've done with the tetrahedron. We are going to do the hexahedron, also known as the cube. Hexahedron, with the same parameters. We're just going to copy this and paste. And actually, we're going to create a variable here. So color is equal to 255,000. So this is going to be the color that will be used for the, or in other words, red, basically. 200 color. There we go. The hexahedron. We're going to follow the same technique with it's the same is so the method to draw it is draw the cube is to draw 3 rhombi, just like with the tetrahedron. Except that instead of isosceles triangle, it's rhombi. Fill in different shades to create the illusion of depth, and that's all it is to it. So it's similar to, so it's basically the same, except that instead of drawing isosceles triangle, we'll draw a rhombi. So set headed minus heading, and therefore I am range 3, fill color, is, int, color. You know what? Just going to copy this because that's basically the same. All right. Now that's done and dusted. Begin fill, and for J in range 2, this is how we are going to draw a rhombus. Forward size, left 120, forward size and left 60. So that's how we draw. So this is a method to draw a rhombus, and an end fill. There we go. And then to turn right 130 to configure for the next rhombus. So I know it's not going to draw anything yet, but set headed 0, and then actually not set headed 0, set headed 15, up, forward 250, then down, and then hexahedron 200, color 330, and oops, oh yes, it doesn't take a value. Why did I put a 0 in here? Anyways, oh, it's just overlap each other. So not 250 but 520. That's going to be much better. And there we go. We have a cube. So I just called it a hexahedron there just to make every shape end with hedron. So because hex means 6 and hedron means the number of sides. So faces, I mean. So basically, I believe it comes from Greek. Anyway, and then if I'm wrong, you can tell me. And define octahedron, size, color, headed. So for the octahedron, it's as simple as draw 3 isosceles triangle, just like within the tetrahedron, exactly the same. Except this time we're not going to turn left 2 by 210 degrees. We're going to configure this in a different way so that there is a triangle. So it's a triangle in the middle, and so instead of turn left 210 degrees, we'll go to turn left 90 degrees. And so when we do set heading 30, up, forward 400, down octahedron, 200 color, 330, and so okay, that didn't go much. That didn't go well. So I must have messed something up here. Set heading. Yes, it's 210 here. So as I was saying, I was talking about here where instead of in this arrangement, I was meant to I drew it in this arrangement because this so base so yeah so so instead of turning left 210 degrees, and I just instead of turning left 210 degrees after everything, I just turn left 90 degrees so that there's a huge triangle in the middle. So that's because that's how an octahedron looks like in a specific view. So there should be a big triangle in the middle, and so that's how an octahedron looks like if you directly look at a specific face. So that's why, and also a few tweaks. All that's left to do now is to just fill the middle tri- fill the middle triangle in with color, and then we're all done for the octahedron. Because all it is just drawing three isosceles triangles like the tetrahedron, and then filling in the middle bit for I in range 3, and then we go to forward size times square root of 3 to draw the middle triangle, and then left 120. And then we also go to set the fill color. So the fill colors go to be 1.5, 1.5, and then the begin fill and fill, begin fill and fill. There we go. Oh, so something went wrong. No matters. Yes, we're supposed to turn left by 30 degrees here, so that it all fits all into place nicely like this. So that's it for so that's everything for the octahedron. Now we're going to. It's just easy. It's just it, it and that's it for the octahedron, and then it's as easy as that. And now we're on to the dodecahedron. Basically, dodecahedron is one of the shapes that look a bit harder to draw, but the reality is it's as easy. It's draw a decagon and draw a decagon and a pentagon in the middle of the decagon that's smaller, and connect the edges up and record the coordinates of the corners so that we could fill the shape in color to create an illusion of depth. And it's not at all rocket science. So 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 this should be easy. No, size, color, heading, and we're going to record the coordinates just to make it easier. Just to make it easier to fill the shapes in color. Corners. It's also set heading. For I in range 5, inner corners dot append X core, Y core. There we go. And then forward size left 32. No, 30. 72. There we go. So that's the central pentagon drawn. Now we're going to draw the decagon. Right 126. And then draw pentagon, and then draw Dodecahedron, right 126, and then forward size divided by 2, left 108, and then for IA range 10, outer corners dot 10 x core, oh no, y core. Actually, I should put it. I should input that as a list. And then, uh, and then, and then if I percent 2 is equal to 0, go to in the corners R2. So for every other corner of the decagon, we are going to connect that to the inner corner of the pentagon, so that we have the pentagonal faces that we can see. And again, go to outer corners I. And note that this has to be an integer, and if we just use a regular divide by symbol, it won't come out as an integer. But if we use an integer division, it's double slash, so it will always be an integer. So that's size divide by 6 times 5. It's just an arbitrary number that I just found out using trial and error. So don't worry too much about it. 36, and let's see what our progress is. Octahedron, set heading, I believe that's set heading minus 10. Minus 10. Go to, no, forward 400, down. Icosahedron. No, not icosahedron. Dodecahedron. 200. No, 150. Color 210. Let's see. Now we have a dodecahedron that's successfully been drawn. So that's quite nice. Now we are going to fill the shape, the faces in color, so that we get an illusion of depth. We already have an illusion of depth, so that's quite good. But now, enough of that. We go to draw. We go to fill in the colors. So, we're going to configure for doing this first. So go to inner corners 0. So just basically to the original starting points and then down. So now we're going to fill front face. We're currently doing for I range 5. Fill color in color. Notice I'm using American spelling this time because I feel like it. I plus 2, and then divide by 2. Lots of brackets I need to be using here. Anyways, we'll deal with it. And then that's it. And then it's just simple copy paste work. The reason why I do this is so that it doesn't get dark very quickly as I continue filling in the faces. So that's why. Why. And yes, I was wrong about it. It was not filling the front face. It was actually to fill the side faces. Fill side faces, and here it's just 1, and it's just 2. Otherwise, we'll just get a white gray. And begin fill. And go to inner corners. I go to outer corners. I times 2. I go to outer corners I times 2. plus 1. Don't worry, this will never get out of range, because go to outer corners I times 2 plus 2, and then percent 10, so that it never gets so that if it is 10, then it will just reset to 0. And I go to in corners I plus 1% 5. Yeah. So basically, those are the coordinate points of every. Those are the coordinate points of every pentagon on the faces of a dodecahedron. And so I haven't actually filled anything yet. That's because I haven't ended fill. There we go. Now we should have a nice filling. Ah, yes, there we go. There's the filled. There's the faces that has been filled in. And now, last but not least, for the dodecahedron, we are going to fill in the center face. So now we go to fill front face. Mm, fill color. It. I'm just gonna copy. I'm just going to plagiarize here, and then it's not really plagiarizing because I'm actually copying from my own work. So there we go. It's just to make things a bit faster, and it didn't do anything because all I've done is just change the fill color of the turtle. I haven't actually begun fill and went over, drawn the area that I wanted to fill in and ended fill. So we're going to do that right now. Begin fill. And then for I range 6, I put 6 because I feel like it, just to reinforce the border in the corners. I said 5, and then end fill. There we go. Now we are going to have the dodecahedron complete. So now this shape is complete, and we have finished drawing the dodecahedron. What a hard shape, but we've drawn it nonetheless. So now we've finished with the dodecahedron. We are now going to draw the most complex looking of them all, the icosahedron. So we are going to draw the icosahedron by drawing a hexagon and a triangle, connect some corners up, record the locations of the corners, use these locations to fill the faces, and to create an illusion of depth. And we have the most complex looking regular polyhedron drawn, as easy as that. So it might look complex, but it's actually easy to draw. So 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 let's get into it. Size, color, heading, and then we're just going to follow the same tactic like here. We're just going to copy all of this, copy the configuration steps, and there we go. And now we're going to for I range 6. So we're going to draw the outer hexagon. So hexagon drawing. I know. I forgot a space, but it doesn't matter. Outer corners dot pen X core or Y core. There we go. So that we were going to record every coordinate on the outer face. Forward, size, and then left 60, and then that's how we draw the hexagon. And if I percent 2 is equal to 0, left 60, forward size divided by 3, so that we get to draw the edges for the inner triangle in corners dot pen X core, Y core, There we go. And then back size divided by 3, and then turn right by 60 degrees. And so there we go. So let's see what our current progress is. So set heading. I'm just going to copy everything here because I'm just a lazy guy. Set heading 5 up, forward, down, and there we go. We're going to set this to 200, and we're not going to draw another dodecahedron. I'm just going to there we go, icosahedron. And yes, now we have it. Now it just looks like a cube with a triangle cut off, or even a hexagon with just three edges just joined together. But it still creates, but it still tricks. Still might look like the cube with a triangle with just the corner cut off. So we are now going to draw the central triangle. So it's as simple as go to outer corners minus 1, go to inner corners minus 1. The reason why I say go to outer, do that in 2 commands is that it doesn't just go there directly and they just leave a trail which would just ruin which will ruin the looks of the what's it called, looks the of the hedron, polyhedron. So now we are going to fill color. It seems like we're going to have to copy from here. Control and then there we go. 1.75, 1.75, 1.75. Now that will just do nothing, so I won't even bother running that. So now, so begin fill, and then for I in range 3. So we're currently filling in fill the front face, fill front face. There we go. Go to inner corners I, and then end fill. There we go. So there we go. So we have a triangular face filled in the middle. So now we are now going to draw the next bits for R in range 3. Fill color is now we just go to copy here because I don't want to keep on typing the same thing over and over again. I plus 2.2, 0.2, 0.2. There we go. So currently we're filling the faces that border the middle face that share a common edge with it. So begin fill. Go to outer corners. I times 2, and then I'll just do it this way instead. Go to inner corners I and end fill. So let's see what our progress is. Yes. So there seems to be some problem here. Bad color sequence tubes. Yes. Didn't mean that. It's actually 2.2 divided by 2. 2.2 divided by 2 divided by 2. So that's what we've been by that, but it's probably. So there we go. We have completed filling in all everything. So what we just did was to fill the faces, the triangular faces that share a common edge with the front triangle. So, so that's what we have just done. So now we are going to fill in the other faces, which is uh, which is for. I'm just going to copy everything here and just create a new loop and edit everything from there. So I already fill color zero. Yes, we're going to use the original. We're going to use the original thing that I've been using for a long time. So we're going to copy this and uh, paste it there. There we go. Fill color. And first, we're going to go to inner corners I. Again, fill, and then I times 2, I times 2 plus 1, 1, there we go, and then go to inner corners, I, and then just to reinforce borders, just to reinforce borders, we're just going to draw a second line again. But that's how we're going to fill some of the backward faces. So it seems like I've done something wrong. Yes, I should have put outer corners. There we go. So now we have finished filling in these faces. So basically we were setting the coordinates for these points. So we're going to call that fill in the side faces. So we're going to copy this again. We'll fill the others. We'll fill the second set of side faces. So here we are going to do I plus 1. Nah, I'm not going to do this. Fill color goes to be on plus 2, and we're going to have to percent this by 6. Otherwise, will just come out as an error, as an index error, list index out of range, and we can't let that happen. So, fill. There we go. And then, so what we're going to do now is I'm just 1.8, 1.8.a. There we go. Just to make it look like a good icosahedron. And there we go. Last time I drew an icosahedron, I wasn't able to fill every individual face up with different colors. And so we have we have a red here. And if you want, I could just turn that into a white color. Um, so that's for the icosahedron. It's done. So our final result we have now is just 4. We just have icosahedron, dodecahedron, octahedron, hexahedron, and tetrahedron. Wasn't rocket science, eh? It's easy as that. Look, it wasn't. It might have looked hard at the beginning, but as you saw, it was as easy. It was as easier than you could imagine. Now, just the last thing to show you, 255, 255. Let's see what happens if we change that into whites. And there we go. We have a we have a much cooler looking thing with grey shades here, here, and also this shade. So that's just something else for you to look at. Also, let's change that into yellow, and then ooh, you can have fun experimenting with these colors yourself. But for now, I have to I but now the subscribe. Maybe check out my new maybe check out my spinning wheel, and maybe also check out how I used to code the icosahedron, dodecahedron, octahedron, and see how And maybe because last time I did it, I had to fill in both of these faces instead of, because there's enough, because I did it, I couldn't fill each separate face separately, and maybe see how much better this is compared to my last video on complex 3D shapes. And also we are also check out my spinning wheel, because that's quite a popular video. And please like and subscribe, and I say goodbye.